Alright, here's our function. In all of its pixelated glory, we see x times e to the 1 minus x. Now the first part is asking us to find the intervals on which f is increasing. To do this, we need to take the first derivative and apply the product rule. The product rule is the first times the derivative of the second, plus the second times the derivative of the first, or vice versa. And when we apply this to this function, we find that the first derivative is equal to negative x times e to the 1 minus x, plus e to the 1 minus x. Now we can factor out an e to the 1 minus x, so that the first derivative is then equal to e to the 1 minus x times 1 minus x. Now, we want to find the critical value by setting the first derivative equal to 0. And as you can see, e to the 1 minus x never quite equals 0 from the graph to the left, which is e to the 1 minus x. So we can ignore that part for now. We just want to look at 1 minus x is equal to 0. And when we simplify, we find that x is equal to 1, which is our one critical value. Now, we want to apply the second derivative test. And to do this, we need to take the second derivative and then evaluate that second derivative at the critical value. So our first derivative is equal to e to the 1 minus x times e to the 1 minus x, which is the same thing as e to the 1 minus x minus f of x, our original function. And this makes taking the second derivative a little bit easier. So the second derivative is negative e to the 1 minus x minus f prime of x, and we already know what f prime of x is, so we can simply plug that back in and simplify. When we simplify, we find that the second derivative is equal to negative 2 times e to the 1 minus x plus x times e to the 1 minus x. Once again, we can pull out an e to the 1 minus x and get the second derivative is equal to e to the 1 minus x times x minus 2. Now let's evaluate the second derivative when x is equal to 1. We find that the second derivative is then equal to e to the 0 times negative 1, which is equal to negative 1. Now because the second derivative evaluated when x is equal to 1 is negative, that means that there is a maximum at this point. So we can say that everything before the maximum is increasing, and everything after the maximum is decreasing. So our answer to A is that the function is increasing on the interval from negative infinity to 1. Part B is asking us to find the range of f. Now, whenever I'm asked to find the range of something, I question what happens as x approaches infinity and as x approaches negative infinity. So first, we're going to evaluate the limit of x times e to the 1 minus x as x approaches infinity. Rewritten, this is the limit as x approaches infinity of e times x over e to the x, which is equal to infinity over infinity, which is one of the indeterminate forms. So now we can apply L'Hopital's rule and take the derivative of the top and the bottom. And we find that the limit as x approaches infinity of e divided by e to the x is equal to 0. Next, we want to see what happens when we take the limit of x approaching negative infinity of x times e to the 1 minus x. And we find that this approaches negative infinity times positive infinity, since x just turns into negative infinity, and e to the 1 minus negative infinity is a very large positive number. So that turns into negative infinity times infinity, which is equal to negative infinity. So this tells us that the range of the function is from negative infinity to the maximum value. And the maximum value, f of 1, is equal to 1. So therefore, the range is from negative infinity to 1 with a closed bracket on 1. Part C is just asking us to find a point of inflection. So this is when the concavity of the function shifts. To do this, we set the second derivative equal to 0. And this is why we did the second derivative test in the first part, because now we know what the second derivative is. When we set the second derivative equal to 0, we see e to the 1 minus x times x minus 2 is equal to 0. And once again, e to the 1 minus x is never equal to 0, so we just evaluate the second part. And we find that there's a point of inflection when x equals 2. Finally, we're asked to draw the function based off of parts A, B, and C. And here we see that the function is increasing from negative infinity to 1, we see a maximum when x is equal to 1, and we see a point of inflection when x is equal to 2. We see the concavity shifting from concave down to concave up. Finally, how many molecules are in a bowl of guacamole? Avocado's number.